Hello, it's time to place some dominoes. Let's embark upon a series of pips. We'll start with easy, see how it goes. All right, we've got to make a 10. We could do that with, it's got to be 6, 4, actually. It looks like we'll need the 0 and the 6 because we've got too much to make out of that. So the 4 and the 0 goes there, the 6 goes there, and then we'll just make 2 3s to finish the 6. Well, 3 3s in total. And there we go. All right, that was the easy puzzle. Let's try the medium one. Okay, we've got a two 4-sized equivalence regions. So what are those going to be? We've got 3s that can do it. 4s could do it. Is it just 3s and 4s that can manage that? I think it is. I think it's just 3s and 4s that can manage it. Okay, so we have a 2 greater than 10. Interesting. So that'll be 11 or 12. So it's either 6 5 or 6 6. And we don't have a single domino version of that, so it'll have to be split. So one of them, the 6 5 6 6, will have to be pointing into this equivalence region, which means what? Either 3s or what was our other option? 4s. Either 3s or 4s are going in there. Okay, so what are the options? We could have this 6 4 going in there. We could have this 5 3 going in there. We could have no. We could have the 5 6 going in there. Right, okay. Let's see. And then we've got a 2, which will need, oh, right. And each of these will need a double, actually, I think. So we've got double 4 and double 3. Yeah, so we've got the 3s and 4s. So we've got one of these is a double 4 somewhere in there, one of them a double 3, and then one of them will have to point into the greater than 10, point into the 2. Okay, so let's see. I'm just going to try the 4s here because, again, I find it hard to keep this all in my head. But this one looks reasonable to me because we know we need one of these pointing into the 2. Actually, I think it needs to be. No, no, because we do have a 3 pointing into a 2 as well. Sorry, never mind. That wasn't a logical deduction. That was just something that is possible, but it also would be possible to have the 2 3 pointing into the equals and then a double 3 down there. Right, okay. And then what about the 3 equivalence region then? Have I looked at that yet? So we've got 3s and 4s in the big ones. And then we could have 5s. Actually, I don't think we could have 5s in here because the 5 would need to point into the greater than 10. Well, I guess it could do it with a 6, actually. If we had a 4 5 here and a 5 going into the greater than 10, we could then have a 5 3. Yeah, I think that might actually be how this works. Then we have a 5 3 going over here, so we have double 3s. So the 4 and the 5 goes over here. Oh, wait. No, I thought about that incorrectly. That was wrong. I mixed up 2 directions. Sorry, this isn't an impressive solve. Let me think about that again. If we had the 4 poking into the 5, we could then up at top have 5 pointing into 6. And then we'd have 5 pointing into 3. Oh, but I've already used that down here. I see. I was trying to use the same domino twice. Okay, does that mean this can't be 4 then? They just need to be 3. I think I was just double counting one domino. Someone asked, are there ever repeated dominoes? And I'm actually not sure. There might not be, just in general in the game. Okay, so then 3 would be pointing into 5. We'd need the other 5 up here with a 6. Yeah, this will work. 6 going into a 4. So yeah, I made a kind of counting mistake earlier. 5s over here and 4 here. Oof, okay, not a great solve of the medium. Let's try the hard, see if I can improve at all. We'll see. Okay, so what do we have here? We have a 6-sized equivalence region. So basically we'll need an example of everything except for 1, because we have 7 possibilities, including the 0. Are they all represented? 1, 2, 3, 4, 5, 6, 0. Yeah, they are all represented. Okay, and we've got a 4-sized equivalence region, which could be 5s or 3s. Maybe just those. We've got a 1 and a 4 here, which we don't have a 1-4 domino, which means each of them is pointing away from each other, or not towards each other anyway. We've got a 6 here, which goes into the inequivalence region. We've got less than 1, which might as well be 0. I wonder why they decided to frame it that way. So let's see. Well, we only have 2 0 possibilities. Can either of them point up? We have a 0, 6 going up into there. That doesn't work. Could we have a 0, 5 going up into there? We'd need 3 more 5s. That does work. That does work in theory. And we also need to make a 10. We've got a 2 equivalence region over. Oh, and another -1. Right. Okay. So both of ours, I didn't realize this. Both of our zeros are spoken for with our, not -1s, but with our less than 1s. So those are fine. So if the less than 1 over here doesn't point into the equivalence region, we would need a double, which could be double 2. I guess it could be double 3 if we're not using the 3 for the equivalence region. And then we've got a 6 over here. And the 6 can't be the 0 because that's spoken for. So actually, we do know the 6 goes here. And either way, it points into the non-equivalence region, which means, whether it's horizontal or vertical, which means we can't use any more 1s in here. Which we couldn't anyway, actually, because we need our other 1, oh my goodness, up here. So that's now correct, because those are the only 1s to which we have access. So now this 4 points into this inequivalence region here, and it can't have a 1 or a 3 on the other end of it, which it already can't. So again, we know that the 4 sends a 4 into the non-equivalence region. Again, it could be horizontal or it could be vertical. We don't know, but it's pointing into it in some way. So these 2 dominoes are not necessarily angled correctly, but they both need certain halves to be in those specific positions. Let's see. So that means this, let's see. Could we use this 0, 6 over here, or pointing? It couldn't point up, but this one could point up, and we'd be able to still make the equivalence out of 5s. If we did make the equivalence out of 5s, could we make our 10? That might not be possible, because then we'd need a 6 and a 4, which we don't have. So the equivalence region is not made out of 5s, which means the -1 is not pointing up, it's pointing across, but we don't know which one it's using. And actually, we can't make the 10 out of a 6, 4 because we don't have a 4. So the 10 must be 2 5s. Does it need to be this doubled 5, or could it be split? It could be split because we have, in fact, it probably needs to be, because we have these 3s going into here. So we would have like 3 there. I'm not certain that needs to be the case, but it feels like it does based on the numbers we have available to us, which would be double 3 there. And then we'd need another 5, which couldn't be a 5, 3. And it couldn't be a 5, 0 because we need that 0. So the 5 would have to be pointing here. And then 1, 3, 4, 5. So we have 2, 0, 6. So we couldn't put the 0, 5 in there because we've already used a 5. So we'd have to put a 0, 6, which means we could put this 3 to finish that equivalence region that way. Now our 2s go into the equivalence, and the -1 is a 0, and that all works. Okay, so I got slightly lucky in the sense that, the directions in which I faced these arrows actually worked. They might not have done, but I was keeping in mind that I wasn't certain that they would need to be positioned that way. I just wanted to get them out of the way since there's no other way to mark dominoes. I'd love to be able to organize dominoes underneath the grid so I wouldn't have to do stuff like that. But anyway, there we go. Made it in the end. Those were the pips. Back tomorrow. Bye for now.